Okay, all that is new students are coming here. Okay, as you all, this is the open elective subject. Hmm? ಯಾವುದಿದೆ ಓಪನ್ itself here the DSDV digital design system using a Verilog ಅಂತದ ಅದಕ್ಕೆ DSDV ಅಂತೀವಿ. What is that? DSDV. This is the open elective subject. This is mainly the EC subject. Okay, what is the subject code? BEC 654A. Okay, BEC. Okay, it's nothing but the electronic subject. Completely, it's the electronic subject, open elective subject. There are two types of elective subjects. One is the internal college, or means departmental subject. That's what we have chosen here. Advanced, advanced Java. Yes, na? Sartotra. Sir, Totra. Totra. It's a okay, advanced Java. You have taken the advanced Java for the internal means departmental choice subject. Okay, this is my open elective subject out of the subject box. Means what? It's out of the your uh, departmental subject. Okay, it's you can choose the mechanical subject, even the any other other than the CS subject. But in this college, almost all many colleges they are taking this what the electronic subject itself, because nowadays after the this era, in this era means what is 10 to 20 years, now electronics will be booming. Okay, there you need to what the some kind of knowledge about the electronics related languages also, so that the CS students, CS branch, this is the open elective subject for the students here in our college they have chosen here. Okay, in this model also, in this subject we have the 4 modules, sorry 5 modules as it is. First module is itself completely basic about the my subject. Okay, what is that subject? Is what the digital design system using a Verilog. Okay, but the completely the overview of the digital design system is the for the HDL, completely basic about what is the HDL, how the HDL program is originated, what is the necessity of the studying of that HDL programming and all. Okay, and also second is what the completely how to write a program, data types, variables, what type of need keywords and all will be studying in the second module. Third module is completely about the data flow model. Okay, you can write the programming in the 3 ways. One is what the data flow model, second one is the behavioral model, third one is what the structural model itself. Okay, as you all studied in the last in the semester DDCO, there you have studied the writing a program for the y equals to AB plus BC. Okay, you have all seen this one, I hope. Y equals to AB plus BC. Okay, as you already studied this one for I have taken this is compulsory. I made the writing a program for this Boolean equation in the 3 ways as the structural model, data flow model, and also behavioral model. That one only basic we are taking. We are involving the complete syllabus is the only on that basic only. Okay, I have to. I know I don't want to explain each and everything here. Somewhat I will be giving the some brief introduction about the subject here. Okay, let me have the some introduction. Okay, here we have the subject name itself as the system design. Just a system design using the Verilog. Subject name itself is the DSDV. DSDV. Okay, the subject code is what the BEC654A. It is also having the same as the 100 marks, 50 marks for the your main examination, and the 50 marks for the internal. Okay, internal marks. Okay, 50 marks. This 50 marks can be divided into two. Okay, one is for the internal 25 marks, internal examination 25 marks, remaining 25 marks to be for the, we don't have the lab here, we don't have the any integrated lab and also main lab also, but for this I will be taking this one is the I will be dividing this is to be 10 marks for the for assignment and 15 marks for the for the seminar. Okay, it's compulsory. All of you have to give the seminar. Okay, and also I'll be dividing this 15 marks itself as the 10 marks for the seminar, 10 marks, 5 marks for the GD. GD also, who will be very active. That one we will be deciding. And this is all about the syllabus. Complete the marks distribution for this subject. Okay, 10 marks for the two assignments you should have to write. Two assignments books, 1 and 2. Okay, it's compulsory. Okay, we'll be writing, if you write the only the one assignment book, it's not applicable. You should have to write the two assignment books. Okay, one I'll keep with me, other one, second one I'll be giving back to you for the study purpose. Okay, how to make a notes and all, I'll be giving each and details. Okay, here also we have the 5 modules. First module is completely about the my subject. Okay, my subject is here the digital system design using a Verilog. Okay, and the about the brief introduction about the Verilog, how it is been originated, what is the HDL, who has invented this, which company they have developed this one. We'll just study each and everything brief about the somewhat history completely about the subject, about the HDL programming. Second one is about the data types. Another one is what the variables and all. We will be studying here, loops and all here. Okay, third one is the how to write a program for the particular design system. In 3 ways we can write. One is what the structural model, second one is the data flow model, third one is what the behavioral model also. Okay, in 3 ways. Okay, each and every model will be having the third one is what the data flow model. Fourth one is the behavioral model. Fifth one is what the structural model. Okay, we'll be studying each and everything, but I'll be taking the classes on the brief introduction of HDL programming and all, and also data types and Verilog. But I'll be explaining the only one type of programming type, that's what the structural or data flow model. I'll not explain these two, because you have to give the seminar on these two models. I will be distributing the each and every topics for all the students. Okay, it might be repeating, all the concept might be repeating, but you should have to come and stand here. You have to give the seminar. It's compulsory. No escape, no excuse. You escape agangilla, ನಾನು excuse ಮಾಡಂಗಿಲ್ಲ. ಹಂಗೈತೆ. ಯಾಕಂದ್ರೆ we need this type of activities for my 7th semester, because you will be in the pre-final students, all are in the pre-final students. You have to have the some idea about the how to attend the interviews and all. I'll be concentrating on those things. But for this one is very compulsory for everyone. It's compulsory. This is the part of my what your career also. This is for your career also. In the each and every interview, they will ask me. They will be asking for you to attend, give the seminar. Just a minute seminar. In a minute, you have to give the talk about the some topics. Come and stand here. You should have to talk. They will be watching each and everything about your language, their hand gestures, and also eye contact and all. They will be checking. For this purpose, I'll be so that I'll be focusing on the these two models on what the seminar. Each and every students have to give the seminar. Okay. Okay, please support and even cooperate with me, because I need your support for your improve your give the correct guidance about your career also. So please be with me as a good student. Okay, don't make any sudden decisions, because I don't want, because I'll be busy with my work, other works also in my college, because I am the training placement officer here. So I'll be having some other works also in the college. So please don't worry. But anyway, I'll be completing the 3 modules completely, and even I'll be with you for these 2 modules also. Each and every student have to give the seminar. While giving the seminar only, I'll be explaining each and everything also. Even I'll be explaining this also. Okay. Next, I'll move to the what is the Verilog. What is the Verilog? I'll be each and so few students will get the irritate. I know, because we are repeating the same concept here today, before yesterday and yesterday also. So let me explain one more time with the brief introduction. Okay, as you all know, the my real world entity can be implemented with what the Boolean functions as y equals to ab plus bc. This is somewhat Boolean function. Okay, we have the three variables Boolean function as the abc as the three variables, and this is my Boolean function. We have the some logic here. What is the logic here? Okay, y equals to ab plus bc. This can be implemented with what? Boolean logic gates. Okay, logic gates. What type of logic gates I can use here? For the dot product purpose, I'll be using the AND gate, and also dot product produces the AND gate, and the one more is for the OR gate. We have the three basic gates as the AND gate, OR gate, and NOT gate, and also we have the derived basic derived gates also, derived logic gates as the NAND gate, NOR gate, and also we have the some special logic gates, okay, which are those NOR and the NAND also. XOR gate is also there. So I'll be using only the here the for this Boolean function implementation only the basic logic gates, which are those AND, OR, and NOT. But how can I implement this this Boolean function with my logic gates? It's designing of what the digital system. We are designing what the one system here. This is what we can say. It's some completely system also. Okay, some system also. So how can I implement this? One can be implemented with the two AND gates because of the dot products as the A, B, and the C. Okay, the B is common, so that I am making the jump connection here. Okay, these two to be feeded. Okay, output of this first AND gate, second AND gate to be feeded to one more OR gate. I need here because of the plus operator. I hope you all following this one. Okay. Okay, this is what the my design. Okay, this is what my design, digital design system. Okay, so that I am okay. Just look at the figure. Okay, what is the this is the digital design system. What we are also looking here, just to observe here, we have the two AND gates, one OR gate, and also inputs are there, only one output is there. How many outputs? Only one output. This is my looking, my digital design system is looking very simple. We have the three gates, two AND gates, one OR gate is there, and also inputs are three are there, only one output is there. What is this interconnection between the two AND gates? We can say it's what the wires. We can say its name as what the wires, W1 and W2. Okay, these are the inputs or wires, inputs. This is the what the output. The wire is nothing but the interconnection between the two gates. We can say name it was the wires. Okay, you should have to make the should not get the confusion. What is where I have to put the wire, where I have to put the inputs and all. But you should remember the connection between the two gates. We can say its name it was the wires. Okay, how can this is what the designing. Okay, I have to implement this one with what the language. Okay, as you all know, the human beings are having the so many different languages to communicate. Even the computer languages also so many types are there. Fortran, COBOL, so many are there in order to communicate with what the processor. C, C++, so many are there. Similarly, I have to explain, describe this digital design system with the one language that one we call what the hardware descriptive language. What is that? Hardware descriptive language, HDL. HDL. These are the hardware components. As you know, AND gate, OR gate, wires. These are what? Hardware components, electronic hardware components. These to be designed, these to be described. One language we call it what the hardware descriptive language. This hardware descriptive language itself have the some. This was developed in the 1980s eras. Okay, 1985. Okay, this one to describe the what the type of hardware components I'm using, how to be explain with the one switch level. We will not bother about this switch level model, but we have to write the we can write the in three ways this digital design system. But all these three ways, whatever the we are writing programming, all are meaning with the only same meaning but the different ways. Okay, one way to write what the first one you will consider the structural model now. Okay, in brief I will be writing the program. Okay, just to follow up. What is the my basic programming here? Just I am giving the some brief introduction. This one you need, okay. This is what the first one I am considering the structural model. Structure modeling, okay. Structure model, okay. What is that? I to start writing the program, okay. First, okay, I am starting the program by writing the program as the first model module, and that's what's the type of program I'm writing. That's the main, okay, not that necessary, but the program name can be written as the any name. It's you can also write the Prabhudev, whatever the name, but in the simple way I'm writing the struct as the struct details, okay. I'm defining the inputs are what are those and also output are what are those. First I'm defining the A, B, C are the inputs and Y is the output, and also putting the semicolon, and just I'm putting the input are what are those A, B and C, okay. Output are what are those, output how many are here, only one, that's what is the what the Y. On the wires are how many here, wires, not the wire just to write the W1 and comma W2, okay. These two are there, okay. Just be ending the program here, end model. In between this one only I'll be writing the some logic here. What I'm writing, what type of program I'm writing, structural model. Structural model is the what are the things, okay. We can also say it's the structural model, also we can say it's what the gate level model, okay, because we are using the gate terms directly. AND gate, what is the first AND gate is there, just AND, second AND gate is also there, AND, okay, third one is what the OR. AND gate can be implemented G1, this is what the G2, this is what the G3. What are the outputs? You should write the first output. What is the output of the first AND gate? W1, right. Input are what are those inputs, A comma B, okay. And the first second AND gate is what the having the inputs as the B and C, and W2 as the output. First you should have tried the first output only, then write the inputs B comma C, okay. Third one is what the OR gate is there. What is the output of the OR gate? Y, just to write the Y, and the inputs for this OR gate is what the W1 and the W2. Why we call the this one is the structural model. Whatever the we are looking on the, just to observe what are the gates. Just I'm giving the taking the those names of the gate itself as the keywords here, as AND gate, OR gate, and all. Okay, that's what we call for the structural model or gate level modeling, because we are using what the gate names directly here. Okay, let me write the one more type of example. That's the here the output is the same. Okay, we are getting the what the type of data flow model. Second one is what the data flow model. First, second module. Always start with the keyword as the module. Okay, what is the name can be any here. Data flow model. You can write any name here. You can also write your name also. The same thing you should have to write. What are the written on the red color? No, you have to write the same as the input A, B, C, and the Y as the and semicolon input. Just to write the inputs alla input ashte barabeku A comma B comma C. Okay, then the outputs are how many? Output only Y. Wire how many? Wire W1, W2. Okay, and the end module. There should not be any space here. End module. Always continuously you should write. And the second, okay, how to write the logic? Okay, for the data flow model. But I will be using only what the only one keyword. That's the what the assign keyword. Assign keyword I am using. What type of gates I am writing here? Just to think about the, this is what the first AND gate. What is the first AND gate output is there? W1 equals to A ampersand of B. For the AND gate we are using the ampersand. Second, assign W2 B ampersand of C, because I'm using here the AND gates here. Okay, just third one is what the assign W3 W1 straight line with the W2, W1 straight line with what the W2. Straight line is used for the OR gate purpose. Huh? W3. W3 ಅಲ್ಲ assign y. Y goes to W1 straight line with the W2. It's OR gate. This is what the we are writing the with assign keyword. I am writing the data flow model. Whatever the outputs output we are getting from the structure model, the same output we can also get from the in the data flow model also. Similarly, I can also write the same program in the behavioral model. As the same is this, as it is model data, sorry, behavioral. You can write any name here, behavioral model. Okay, inputs are what are those? A, comma B, comma C, Y, and the input A, comma B, comma C. Output are what are those? Y, and also wire. I have the wires here, which are those W1 and W2. And this is the end model. You can write the same here also. But the logic behind this programming is here what the I'll be using the two keywords. One is what the register keyword, another one is what the always at the rate. Always at the rate. But register keyword is used to write the for expressing of what the only the outputs. What are the outputs here? W1 W2 is also output. Output adava W1 W2 output antara illa yaka wires adava, because always register is what the with only one output, that's what the y is the only one output. Okay, always at the rate you have to write what here the only inputs. What are those? A, comma B, comma C. And also you can write the logic in this. Okay, what is the logic here? The y equals to A ampersand of B and B ampersand of C. Okay, but what I am using here the OR gate. For OR gate purpose I am using what the straight line. Okay, here you can observe here there is no abstraction here. Whatever you are looking at the digital design system, that's what that one only we are expressing in what the words. What the AND gate is there, AND gate, OR gate. Directly I am giving the names as it is, and also defining the wires also. There is no abstraction. This very low level writing of the program, low level design this one. But in the data flow model we have the somewhat some abstraction is there. We will not get any details about the digital design system. If you have the more complex in the digital design system, I'll go with what the data flow model. If it is more complexity is there, then I'll go with what the behavioral model, because with in the behavioral model we have so much of abstraction here. We will not get we are not defining any inputs, outputs, and also we are not bother about the simple step by step. We will not write directly. We are writing the output here with the inbuilt interconnection and all. Okay, compared to the structural model, behavioral model have the what is the high abstraction, more abstraction we are having here compared to the structural model. Compared to the data flow model, behavior model having the how much so much of abstraction here. Abstraction is nothing but we do not get the in detail. Okay, if any my digital design system is very simple, then definitely I can write the programming in the structural model itself. If it's more complex, then I will go with what the data flow model, and also even go with what the structural behavioral model also. Okay, this is only about the somewhat writing of the program for the digital system in the three ways. Okay, by using this basic only, we will build the third model, fourth model, and also fifth model. If you know the somewhat basic about this one, we will be writing the in detail big logics. Okay, digital system design can be designed this is what the very simple logic I have written here, Boolean function. There will get you need to write the program for the half adder, full adder, not those type of logics. You need to write some combination logic circuits, even the sequential logic circuits also. There you have to write the programs for the third, fourth, and fifth model. Very easy. language is there, this one is there. Okay, don't worry, I'll be each and everything I'll be explaining in detail. Okay, I'll not escape. Okay, single concept adru nan bidalla. Yavadu bidalla. I'll be explaining each and everything in detail. Don't worry, but please be with me. Okay, that's what I'm requesting you. Okay. Okay, I hope you all followed this one. Okay, the same output we are getting, okay, from the structural model, data flow model, and also behavioral model. Why we are writing? Same output we are getting from the all these three models. But thing is that if the complexity in the what the digital system, then I'll go with the different types of designing what the language, what programming types. One is the what the structural model programming. Second one is what the data flow model programming. Third one is what the behavioral model programming. But in this, for this basic, this Boolean function, these different types of programming ways, we will get the only one output. Same output we are getting, will not get any other changes here in the output. But in different ways we are written here for explanation purpose. Okay. I hope you all followed this one. Okay. So open elective subject means what? The completely it's a very easy subject. You should remember. My subject is here the where is where. Okay, we don't have the any lab here. Integrated lab illa, NB illa. Okay. Shall I erase this one? More credits. Okay, in this for this subject we have the 3 credits. Okay, 3 credits. Okay, we are not getting any notes from the VT website itself, but I will be making some notes for you, each and everything. And also we are not getting any question papers for this subject, but I will be getting, I will download from VT site. Don't worry, each and everything I will provide you. Don't worry. Okay, now the look at on the system. Okay, DSDV. Okay, DSDV. What is the digital system design using a Verilog? Digital system design using a Verilog. In this we have the 5 models. Module 1, 2, 3, 4 and 5. First module is completely about the basics of the HDL, evolution of the HDL programming. VHDL programming, evolution of the HDL program. ಯಾವ ತರ evaluate ಆಯ್ತು, ಯಾರು ಡೆವಲಪ್ ಮಾಡಿದ್ರು, ಎಲ್ಲಿ ಡೆವಲಪ್ ಆಯ್ತು, ಎಲ್ಲಿ R&D ಆಯ್ತು, completely will design studying here. Okay, second one is what type of data types we are using, what is the variables, what are those different parameters we are using for writing a programming. Some basics of the programming will be studying in the second module. Okay, third module is what? The data flow model. Third module is what? The data flow model. Third one, fourth one is what? The behavioral model. Third one is what? The fifth one is fifth one is the structural model. Okay, structural model. But anyway, I'll be taking the class as I already told you. First model, second model, and the fifth model. First model, second model, and the fifth model. Okay. But I will not take the data flow model, behavior model. You should have to explain me. Okay. First, we will consider the first one is as the evolutionary of the HDL program. Today, we will start with the syllabus itself as the first module. We will consider first chapter itself as the evolution of the computer aided design, digital design system. Okay, overview of the complete the digital design with the Verilog. We'll consider first one. For this, you have to refer the two books are there. One I did not get. Okay, first one is what the this is the complete book for the for your syllabus. Okay, what is the Samir Politekar? Okay, Samir Politekar. You can refer this book. Okay, this is already available in the library. Okay, just go and collect it. Okay, so many books are available. Okay, if you are not getting, then definitely approach me. You will not get the any notes. You have to make the notes on the subject. Some notes ಸಿಗ್ತಾ ಇಲ್ಲ VT site ಅಲ್ಲಿ ಎಲ್ಲಿ ಸಿಗ್ತಿಲ್ಲ ಬಟ್ ನನ್ನ ಬಳಿ ಸಿಕ್ಕರೆ ನಾನು ಹಾಕ್ತೀನಿ ನಿಮಗೆ. Okay, credits for this subject is what the 3 are there. Okay, today start with the programming. Okay, the my syllabus itself, first module. Okay. Thank you. Okay. Module 101. We'll start with the syllabus today itself. Okay. Okay, till now what I have studied, that's all basic about the my subject. Today we'll start with the first module, that's the evolution of HDL programming. Evolution. Okay, the overview of the completely first chapter, first module itself, the overview of the overview. Overview of HDL programming. First module name itself, overview of the HDL programming. In this concept, we have the in this chapter we have the so many concepts: evolution of computer, evolution of CAD. That is nothing but the computer aided digital design. Okay, computer aided digital design, evolution of the CAD tool, and also emergence of HDL, and also typical design flow. What that type of flow will be referring here. Okay, and also we have the importance of HDLs. This looks very simple, but the theory is there completely first model. We don't have any programming here, completely theory about the my HDL programming. Importance of HDL and also popularity of the Verilog HDL and also trends in the HDL. Okay, trends in the HDL. Okay, this is all about the first module. First module in the first chapter. We have the this type of concepts here. syllabus. First we'll consider the, this is what the evolution of the CAD design tool and also emergence of the HDL. Third one is the typical design flow. One tip flow is there, how to design a and also write a programming for the synthesis of the this complete the HDL programming, and also importance of the HDL, what is the necessity of studying the HDL programming itself, and also popularity in the popularity among this HDL programming, why the popularity happening, popularity in the VHDL, which VHDL ಯಾಕೆ popularity ಆಗಿದೆ ಅಂತ we'll be studying. We have to give the some reasons, some points over there, and also trends in the HDL. We have the some different what type of trending is happening, why is evaluating, ಯಾಕೆ ಇಷ್ಟೊಂದು ಪರಿ R&D ಮಾಡ್ತಿದ್ದಾರೆ. We will be studying in the these concepts also. First one will consider the evolution of the CAD. Okay, CAD design. CAD design. Over the 25 years back, the HDL program was developed. Okay, over the 25 years back, HDL programming was developed. And also what is the necessity? Okay, usually the our digital system designs usually implemented with the vacuum tubes, and also transistors. Okay, with this to be whatever the digital system you have seen, the AND gate, OR gate and all, whatever the NOT gates which they are implemented, no, that is to be implemented with what the vacuum tubes and the transistors in the earlier of the 1983. In 1983 earlier, the vacuum tubes and the transistors are used to implement the digital design system. Okay, this to be implemented on a what the ICs, integrated circuits. Okay, we'll have the different types of integrated circuits. First one is what the SSI, second one is what the MSI, third one is what the LSI, fourth one is what the VLSI. Okay, SSI is nothing but the small scale integrated circuits. Small scale integrated ICs. MSI is nothing but the medium scale. And also third one is what the LSI. LSI is nothing but the large scale integrated circuits. VLSI is nothing but the very large scale integrated circuits. Okay, SSI is nothing but the small scale integrated circuits. Here the around the 10 to 20 transistors or vacuum tubes are used to design ICs. Okay, 10 to 20. Okay, here the medium scale is nothing but the, here the hundreds of transistors are used to build a what the ICs. And also here the large scale integrated circuit will have the thousands of IC, what the transistors or vacuum tubes are used to implement the design or implement or on a chip. Okay, that's what we call the ICs, integrated circuits. We'll be using this type of ICs. We'll have the thousands of integrated IC means transistors and all. Here the VLSI consists of the millions or billions of transistors are used to or implement a ICs on a chip. Okay, we will be using this type of chips we are using. Okay, this is what we have developed here. SSI is nothing but the small scale integrated circuits. LSI is nothing but the MSI is nothing but the medium scale integrated circuits, and also LSI is nothing but the large scale integrated circuits. And this third is for the most trending one. This is for the most trending one. This is the VLSI, very large scale integrated circuit. This is my master degree on this subject only. MTech, VLSI. Part of this my master degree. VLSI design and embedded system. Okay, yearly, paragilla. Very large scale integrated circuit. Okay, we'll be studying here, and also what are the things, okay, whatever they will be deployed, no, these ICs with the help of what the transistors, whether we got the correct ICs or not, we have to check with the help of what the one tool that we call what the electronic design automation tool, EDA. EDA is nothing but the electronic design automation tool. Automation tool, okay. This one we were using the techniques, okay, in the EDA tool. EDA tool is used to whether we are got the check the test the whether the ICs are correctly we are getting or not. You can find this type of EDA tool in the electronics branch, ENC communication, electronics communication branch. In the branch you can find this one. EDA tool is this is available already. EDA tool is used to check the whether the ICs are working properly or not. They will check the each and everything. If you insert the any IC on the EDA tool, that one will support. Okay, it will test the whether it's these ICs are right or wrong, whether it is working or not. It will check. Even it will be checking the resistors, transistors. So many things are there. It is a testing tool, whether the hardware components are working properly or not. Okay, EDA tool is used to test whether the components are working properly or not. We will be using. The main circuit is still tested, okay, on the breadboard, and also even the layout of the design, whether the properly designed or not, with the help of the EDA tool also. Sometimes this EDA tool is also used to check, okay, whether the circuit design is properly designed or not, even on the breadboard, even on the different types of layouts also. Okay, CAD design tool. Okay, this is what the one of the tool which is very popular in our nowadays, and also designer has to be build, okay, different levels of gate levels design, even the different types of simulators you are using. Simulators are nothing but the simulation is used to test whether my gates are working properly or not. Gates are nothing but whether the ICs are working properly or not. Simulation, okay. We will be checking each and every time. We will be writing the simulation code for the whether properly the gates or chips ICs are working properly or not. We will with the help of the simulator or the test bench. We will need to write every time the test bench. Writing the test bench we call for the simulation. Whether we will be checking whether my design tool or whether my digital system design is working properly or not. If it is my design, let me consider the one example, AND gate. AND gate can be implemented with the help of what the hardware. Okay, this is what the design. Okay, this is the graphical symbolic representation A, B, and the Y. How many inputs for the AND gate here? Sneha? How many inputs are here? 2 inputs. For NOT gate, how many inputs are there? Only one, na? 2 or 3? 1. Right, you are right. Because you are my student. It means what so many students from the Bidar, some other college students, they don't know how many inputs for the NOT gate. Okay, how to write this one? Whether with the I have to check this digital system. Okay, what is that? Is this gate with the help of for the input combination? What is that? Input combination can be sent through what the one we call is what the truth table. Okay, A comma B. Y is the output here. 0 0 0 1 1 0 1 1. As you all know the what is the Boolean logic gates? What is the Boolean binary variable? Binary is nothing but the two values it can have, zeros or one. By means what? Two zeros or one. Any variable in the world, real world entity can have the two values. Which are those? One or zero. We have the here the how many variables are here? Two variables are the A and B are the two variables. Yes, no? 2 to the power of 2, how much? 2 to the power of n combination. I need what? Here the two table here. Okay, 2 to the power of 2 is how much? 4 combinations of input size I have to send. 0 0 0 1 1 0 1 1. Okay, what is the operation for this AND gate? It's the product form. It's combining what? Multiplication. 0 0 is what? 0 0 1 is what? 0 1 0 is what? 0 1 1 is what? 1. So I have to send this one with the input combinations. Okay, I can check it. Okay, with the help of what the simulation test bench. Okay, if it is only one input, I can check whether it's right or wrong. I can check, but I have to send what the input combinations. That's in the form of what the test bench. This one we call this testing of this one with the we can say it's what the simulation whether it's working properly or not for my input combinations. And also designer could be able to write what the functional bugs, whether the if it is a giving, if it is not working properly, he has to designer has to find out that bug, means what the find out is that error, he has to rectify that error with the help of what? Simulator itself. If it's sending if it is not working my input combination, definitely it has some errors in the programming. That's what we are sending. This one is the we call the simulation. Okay, simulation is to be done with the help of the what the while sending the input combination for this my digital system. This one you call the sending of the testing of the digital system with the help of what the EDA tool. Even what the for the EDA tool is used to for the testing of the hardware components. But whether it is hardware component is working properly or not, I have to check with what the input combination with the help of the software. That means what is the simulation. Whether my program is whatever the hardware components have to be have the some program inside. This program whether it is working properly or not, I have to send. I have to check with the help of what the input combination. That one we call is what the simulation. With the help of for the test bench, while writing the test bench I have to send the input combination in the test bench. After that test bench I have to simulate it, means what I have to check whether completely whether my inputs combination is this digital system is working properly or not. We call towards the simulation. Okay, this is all about what the evolution of the my CAD tool. How the CAD tool come into existence? Computer aided design tool, design digital design system, CAD tool. This can be achieved whatever I said until now explained. This can be achieved with what the CAD tool. One tool is there. What is the Eclipse and the Java salagi. Similarly, this can be my digital system can be completely tested whether it's working properly or not. Can be designed in the what the tool CAD tool. Okay, I hope you all following this one. Okay, this is all about them. It may be asking for the 5 marks for this write evolutionary about the HTML program. You have to write this much only about this all. Okay, next topic is here the emergence of the HDLs. Emergence of the HDLs. Just copy this much. I hope copy ಮಾಡಿದ್ರೆ
Thank you.